All right, so example number 3 from 4.6 asks us to graph a composite function of sine of x and x cubed. And so what I'm going to do is I'm going to take sine of x and we're going to plug that into the function x cubed. Essentially, we're going to create a composite function of 3x cubed, which is really 3x cubed. We just write it a little differently. Also, they want us to find the domain and the range and the period of sine of x cubed. So the easiest way to do that, and not only that, we have to prove that the function is periodic. So remember that the domain is figuring out what the x values are, range is what are the possible y values, and the period is one full cycle or wavelength of the function. So if it is periodic, a pattern will repeat forever to positive infinity and also in the other direction to negative infinity with regards to the x-axis. Now, one of the easiest ways to do that is just to plug it into the calculator and then kind of use our knowledge of sine of x to figure out the other things, right? So we can figure out things mathematically. So we'll graph it, and then what we'll do is we'll come back and we'll try to figure it out mathematically. So sine of x has an original period of 2 pi. So if I go into my calculator and I plug in sine of x cubed, now remember that's what it means, it's sine of x cubed, not sine of x cubed. It sounds funny when I say it. So when I graph it, it kind of looks like sine, right? And look, there's a little bit of a variation of the way that it looks, but it does look periodic. So one of our goals is to find out what that period actually is. When we look at the domain, though, it makes sense. The domain is actually going to go from negative infinity to positive infinity. There are no restrictions on the domain. No square roots that might be negative. And sine doesn't appear to have a value that's undefined. Because remember, on the unit circle, sine of theta is equal to the y value. So the y value can be 0, it could be 1, and it could be anything in between. So I'm going to adjust my window here to zoom in a little bit just to kind of verify some things, but the domain appears not to have any restrictions. There's no issue with x values. The range, however, when I look at it, it appears to go from 1 to negative 1, but we'll talk about that in a minute. So to figure out what the period is, I remember that sine of x has a period of 2 pi. So if this is periodic, then my function f of x should yield the same value of x plus 2 pi, because that's what periodic functions do. So what I'm going to do is I'm going to go into my calculator and I'm going to arbitrarily pick any number for x, find out what my corresponding y value is, and then evaluate my function again at that same arbitrary value for x plus 2 pi. Now the easiest way to do that is, once I have it graphed, is to simply hit the trace button, enter in an x value, see what my corresponding y value is, and then repeat that with the x value plus 2 pi. That's one thing we can do. So essentially I'm going to say f of, and I'll just pick the number 1, and then f of 1 plus 2 pi. Now if this is periodic, and it does have a period of 2 pi, I should get the same y value. So let's try it. I hit my trace button, I hit 1, hit enter, and when I hit enter, it's going to give me the corresponding y value. Okay, and so when x equals 1, my y value is equal to this number here. Okay, so let's write that down. F of 1 is equal to, and that's approximately 0.6. All right, so now what I'm going to do is I'm going to hit trace again, and this time I'm going to plug in 1 plus 2 pi, and what that means is that if I shift from here in the x direction 2 pi units, approximately 6.28, I should end up at the same y value, one full wavelength or cycle. So let's try it. Trace x equals 1 plus 2 times pi. I hit enter. And if it is periodic, I should go from here to here, one full wavelength, and have the same corresponding value. Now, because we're dealing with trig functions, it's always going to involve pi. 2 pi may be the answer or may not. In this case, it looks like it is because it shifted over exactly 2 pi in the x direction, and my corresponding y value is approximately 0.6. So it does appear that the period is 2 pi. It's one wavelength. One wavelength is equal to a period. In other words, how much did I shift in the x direction to have one full complete wavelength? And it appears to be 2 pi. And so when I look at the graph, there's no other changes for that. What I could do is plug in 2 plus 2 pi and put in a couple of values, and if I get the same corresponding y value, I feel pretty comfortable. The last thing we need to talk about is the range. Sine of x has a range of 1 to -1. Now we're essentially just taking those y values and raising them to the third power. So the maximum value for sine is +1. The minimum value for sine is -1. If I take -1 and raise it to the third power, it equals -1. If I take the maximum y value for sine, raise it to the third power, the maximum value is 1. I can trace the graph and get the same exact value. Okay? That's it. Any questions?